Welcome, this is Mark Schuyler. We're going to take a quick look at the equation of a circle. I'm going to make sure you're prepared for any question that even slightly, remotely involves the equation of a circle on the SAT and the ACT. So let's start off with the equation itself. And yes, you do need to memorize this. This is one of the missing formulas that you have to know if you want to get this question right. And there will be one question about the equation of a circle on both tests, for sure. It's mandatory. So here's the equation: x minus h squared plus y minus k squared equals the radius squared. That is our equation of a circle. And some of the simpler problems just provide numbers to you for the h, for the k, and for the r. And let me give you an example of that. You might see this problem on test day. You might see x minus 4 squared plus y plus 2 squared equals 4. Okay, so let's start talking about the traps that the test makers set for you. They want to fool you with the radius. Yep, that's their goal. They want you to think that the radius is 4. Yep, they're going to have that trap answer in all the time. But you can see that 4 is the radius squared. So really, if the radius squared is 4, then the radius is 2. And we have to see that about half the answer choices are going to give us a choice of 2 for the radius. The other half of the answer choices are going to give us 4. Don't fall for that simple trap. Here's another thing. When you take the number that's in the h spot of the equation and you take the number that's in the k spot, you have to put them together because, as you see over here in my diagram of a circle, the h is really like the x-coordinate of the center of the circle, and the k is really like the y-coordinate of the center of the circle. So they're going to try to trick you into thinking -4, comma, +2. They're going to want you to think, oh yeah, that is the circle's center. But it's not. Nope. Instead, it's +4, comma, -2. The signs are actually changed from what they look like when you're reading the equation. Why is that? Well, I'll definitely explain that. But for right now, just go with me and just know that the sign changes, that this is not right, that it's actually x is 4 and y is -2. So that would give us our center. Let me go ahead and put it over here and label the diagram. What I have so far for -2 is correct. Our radius is 2. All right. So we could position this now on the XY coordinate grid, and we don't need a graphing calculator. We can interpret it from just seeing some numbers placed into the equation of a circle. By the way, sometimes you get a really stripped down circle. Let me show you what I mean. You'll see the equation just x squared plus y squared equals, say, 9. And you're looking at this and you're like, wow, that's really simple. Just x squared added to y squared. Where's all the parentheses? Where's all the -h and the -k? Well, it's because 0 is actually your h value. That 0 is your k value. This circle, the one right here in blue, that's centered right over the origin of the XY coordinate grid. Its center is right there at 0, 0. So who would bother writing out x plus 0 squared? Let me go back and just change that. Who would bother writing out x minus 0, if I would just want to keep my signs right for the equation, plus y minus 0 squared equals 9. Who would bother with that? No, just write it out as simply as you can in the most reduced form. So that's why we have just x squared plus y squared equals 9. Again, don't fall for the trap. The radius is not 9. The radius is 3. Yes, with our 0, 0 as our center, if you have such a stripped down equation. Okay. Now, let me move on to the next page. What I want to do is show you that that's not enough. What I've just taught you can definitely get you the points on an easier circle question, but they often ask much harder circle questions. Let me give you an example of what I'm talking about. Here's our center. Let me just draw in the radius. I'll label it. Here's our HK center. Okay, so what they might do is they'll give you an equation and they will say it's the equation of a circle, but it doesn't even look like it. Here's an example. It'll be something like x squared plus 4x plus y squared plus 6y equals, let's say, -4. Okay. Now, first of all, you can't even have a radius squared equal to -4, can you? So right away, you know something's really messed up here. You can't have a circle with a negative radius. So what would it be, a black hole? So something is really strange about this, and a lot of people don't know how to handle it. So I want to teach you how to prepare for this kind of question. You're going to have to do something called completing the square. You might have a very vague memories of this, or maybe you'll know exactly what I'm talking about. But completing the square. Completing of the square, yeah. Let's talk about that. What you do is you have to figure out what number comes after the 4x and what number comes after the 6y. Because what you want to do is end up having this and this end up being factored into perfect squares. So here's the procedure. Let's start with this +4. Cut it in half and square that. So what's half of 4? 2. What's 2 squared? 4. So let me change colors. We're going to put in a +4 right here. We're just putting it into the left side of the equation. But if you do that, you instantly have to balance it out by putting it in on the right side. Now, let's complete the square on the y side of our equation. We have a 6y, we cut it in half, and we square the result. 6 cut in half is 3, 3 squared is 9. We're adding 9 to this side, which means we better balance the other side of the equal sign right away. Right away, don't wait, put in the +9. And now, look at this. We can take this part over here on the right side of the equal sign. We can add it all up. And notice the -4 and +4 cancel. You end up with 9. Remember, don't fall for that trap. The radius is not 9, but the radius squared is 9. So the radius is 3. Now, let's go after getting the center, the exact center of the circle, the HK center. Maybe this is one of the easiest polynomials in the world to factor by hand. I've had very few students not know how to factor this. It's basically x + 2 squared. And if you took the time to FOIL that, if you went first, outer, inner, last, and you did the long distribution, you would have x squared + 4x + 4. Now, let's take a look at the y side. The y side, y squared + 6y + 9. Well, that's a little bit harder to figure out what that is as a perfect square, but it's still pretty easy. It's y + 3, because if you FOILed y + 3 times y + 3, you would end up with y squared + 6y + 9. Put the plus sign between these. I'll put my 9 over here. And suddenly, check it out. This is the reason we went to the trouble of, quote, completing the square, is we now have our equation in a form that matches the known equation of a circle, right? The known equation of a circle, I'll remind you again because it was on the other page, is x - h squared plus y - k squared equals r squared. So we come down here and we have to remember that the center is not +2, 3, right? That's not right. We have to change the signs. We're really going to be using -2 and -3. Why is that? Well, the equation, the equation that's the right equation of this circle is right here. So let me circle it in a very bright color. I'm going to circle it in this very bright green. This is our circle's equation. It took us a little while, but we got it all figured out. Okay, let's try that again. Circle this. Yeah, it's a little bit better. Now, remember I promised you I would explain why the signs change. So I'm doing that right now. The original equation of the circle is up here. You can see x minus h squared plus y minus k squared equals r squared. And this circle's proper equation is x plus 2. If you drop in a -2, if -2 is really the x coordinate of the center, and you drop in a -2 for h, you're going to be minusing that -2. And when you minus a -2, it would actually give you the equation which we have, which is x plus 2. And again, we have a y minus k. If you drop in a -3 right up here for k, you're minusing a -3, so it's going to read as y plus 3. This is why we have to change the signs. So I hope that explanation made a lot of sense. Notice on a simpler problem, let me go back. All you need to know is how to deal with the radius and the sign changes of the h and the k, because they just provide numbers in those spots, those 3 important spots. But on a harder question, as in this one, you have to do some work to put things into, via completing the square, you have to put things into the equation of a circle form. So we're going to practice this one last time. I'm going to go to a new slide. I'm going to draw another quick circle here, and I'm going to give you its equation. Let me use this. Okay. And notice how it looks kind of scrambled. X squared plus 6x. Let me scramble it even a little bit more. I'm going to write x squared plus y squared plus 6x plus 4y equals, I'm just going to make this up. Let's say we're going to make it 4. So the first thing I would do is some grouping. I would get the x's close to each other. I think that's a smart thing to do, and get the y values close to each other. And remember, we want to leave a little space, for being able to complete the square. So let me move this equal sign a little bit over to the right and give myself the room I need. Look at that. All right, so in here, what's half of 6? 3. 3 squared is 9. I'm going to add 9 to this side, which means I instantly add it to the other side. I don't want to forget. Got to balance out my equation. Half of 4 is 2. 2 squared is 4. I add another 4 here. So I have my r squared is equal to 17, which means the radius is a pretty ugly number. It's the square root of 17, but that is the radius. And then for our completing the square to finish off, to figure out what our HK center value is, the center of our circle, we're going to say it's x plus 3 squared plus y plus 2 squared. So that would mean that we really have -3 comma -2. This is our center. Yes. And I'll come over here and point out that that's the exact center. So that's all there is to it. Try to work my way through that as quickly as possible without going too fast, and look forward to our next lesson when we go over another facet of circles. Take care. Have a great day.